always the hardest part. Let's get forward on the slides. So I'm Harry Mendell, and before I say anything, the Federal Reserve requires me to say that everything I'm presenting today is my opinion and not the opinion of the Federal Reserve. So I've gotten that out of the way. So for those of you that don't know what the Federal Reserve does, we're in charge basically of financial stability within the United States and in some cases beyond. And we make sure that the banking system runs smoothly. And since the crash in 2008, we've had more supervision of the banks to make sure that a lot of rules are followed and put into place to make sure that everything runs properly, whether it be checking money laundering or whether it be controlling various risks. And doing this requires our supervision area to examine a tremendous amount of information from banks. You've all heard of the stress tests and things like this. And in addition to that, we collect over 500,000 documents, and some of them are very big, from the banks, which our examiners have to read. So you can see that there'd be an application for natural language processing there, which I'll first talk about, but there's a lot more than that. We're concerned with all kinds of risks, and risks that could be affecting financial stability, including climate risk, including other types of natural hazards. The Fed was very involved in rescuing Puerto Rico. Besides, FEMA, we were doing it financially after the hurricanes, and Florida recently, and certainly during the pandemic, we put lots of things in place. And all these things have to be monitored. So what I'm going to talk about today is the different ways we can use AI and ML to do a better job at what we're doing. And I'd like to give you an example first. So one of the first things that I did, one more thing I wanted to say. At the Fed, I'm co-chair of the Innovation Roundtable for AI and ML, and also in data architecture at the Fed in New York. So one of the first things we did is put together a natural language processing system for handling all these documents I talked about. As you see, there's a continuous stream of documents which come in. And one of the things we're interested in is what new topics may be showing up in these documents, because that way we can become aware of threats that we weren't looking at before. We also just need to go through a lot of documents. And before, the examiners were reading a lot of them, but not everything, because they were overwhelmed. So we're trying to help them with that as well. And so what we created is a system called Lex. I know there's a lot of things called Lex now, but we came up with that before Amazon did. But in any case, it's a language extraction tool. It goes through all the documents and pulls out things, concepts, which the regulators are interested in. And I'm sure most of you know what word embedding is, but let me just say a few words about it. It's a way of representing words, groups of words, and sentences mathematically, so you can find things which match them without having to look at keywords, regular expressions, and things like that. You can simply, say risk, and it will match something like volatility. This way, we can construct search criteria which can be tuned to different things the examiners are interested in. So words, phrases, sentences. We can also generate statistics on these, so you might want to look at a chart, for example, of pandemic risk and see how it changes over time. Or you might look at how people are satisfied with the board or not over time, because we're concerned with our reputation, among other things as well. Because sometimes people feel we could be doing a better job managing the economy. This is an example of something from our climate model. So anthropogenic means related to the environment and carbon. And basically, if you put this into our model, these are the top concepts which come out. And as you can see, nothing about it matches the word, but it matches the concept. And that's the whole principle behind Lex. So you can create Boolean expressions of words and phrases, and it searches through all the documents and compiles reports, which the examiners find to be very useful, and can actually extract text as well, so they can see highlighted what causes the statistic or the count. And they be looking for particular things which they need to read to take further action with. So one of the use cases is money laundering. And we ran a test when we first put the system together where we wanted to see what the model could do, Lex, versus what the examiners would do. And we used this to iterate around the design until we were able to get at least 85% of what the examiners found in the documents. Plus, we found additional things which they didn't find. So it's been expanded and used to other areas. And this is what it looks like to the examiner. They originally wanted to get reports because they used to highlight them in yellow in Adobe and then pass them up the chain, and that's how the people solved this problem. And initially they said that's what we want as well, so we actually had to figure out how to find the right pixels on the Adobe document, which was a whole story in itself. But we did it, and we also put it in a database where we thought it belonged, and they can search. And the documents are complicated. As you can see, a typical document, this case was 231 pages, plus Excel spreadsheets. We had to be able to parse and go through all that and analyze it. These are some of the other areas that we are examining. We have 30 of these topics running now. And one of the things which made this program particularly popular, this was all done prior to the COVID pandemic and the lockdown, but after the lockdown, we couldn't send our examiners into banks. So the Federal Reserve was fortunate to have the system in place, so they relied on it for continuous monitoring of what the firms were doing. Because before we would send people in and they would have a conversation, they would be pointed in the right direction, and the correct documents might be identified that way. This way we were running without the benefit of those conversations, and it turned out to work out well, and now they're still using it for all this. So that's all I'm going to say about that, except we only have half an hour to cover a lot of topics. Another problem is how do we get data? So I'm sure everyone in this room doing data science is concerned about getting the proper data to train models on. And at the Federal Reserve, we have all kinds of data, but we have a lot of security because a lot of the data is very confidential. Excuse me for saying that. Talking all day. So the problem is, for example, the bank documents which we had to train our model on were classified as something called CSI, which is the confidential, not sure what the rest of it stands for, but it's secret bank information, it's balance sheet information, it's memos, it's meetings from internal meetings of all the major banks and can't fall into public hands. So you can imagine it wasn't easy training models on that. And we had to go through a lot, which I don't have time to get into right now. But catch me later and I can tell you how we figured it out. But what we wanted is something that's more general and applicable to all the other types of data that we have. And you can imagine with all the fund transfers that go through the Federal Reserve and all the other statistics and things, it's a gold mine for data scientists. How do we get the data? So what you need is a way, first of all, for people to find out what the data is. So we're putting in place a catalog system which will go through all the different databases throughout the Fed and collect metadata and examples of the data so data scientists can search through the catalog and find out what they want. Then it can decide based on what their role is within the organization whether or not they might have permission for it. If it can't make a decision automatically about whether to make the data available, a human gets in the loop and they request and they'll be permissioned within a day. At least that's the service goal. or not. The other things that we find is we really want to move from periodic to real time because things happen quickly and we can't wait for quarterly reports to react to them or even monthly reports. So we're redesigning our systems to be stream driven and event driven so dashboards are updated properly. This is not working now, but it's under development. I'll mislead you. And we feel that's the way to go in general for regulatory agencies that need to respond quickly. And they're enabling technologies that allow this. There's two in particular that work well with streaming. There are others. We're looking at both Kafka and Pulsar and doing POCs. And the other thing to keep in mind is that different databases respond differently in terms of latency and analytic capability. And it's important to separate the data from the compute because it all depends on what the application needs to do. So we've called this, and a lot of people are calling this, we did not invent the term, but people refer to this as a data mesh. You may have heard this come around, and that's what we're calling the project. So the core tenets is that you have data as a product. So you would have a group which would be responsible for the different data sets, and the data would be vetted and then sent to the catalog and indexed with the metadata and put into the system, along with the governance rules. And there also has to be a, this is the data catalog. There also has to, sorry, I went too fast. There also has to be policies written in place to automatically decide whether the data can be accessible to the group trying to access it for the modeling. So this is another component of it where part of the system, the part that isn't transactional, for example, wouldn't be used in a payment system, but would be used in an analytic system, are things which rely on technologies such as Trino. Starburst is a vendor which supports this. There are others. And essentially, it allows you to take SQL requests and have them fanned out to databases, whether or not they're SQL databases. So that's the key. You could have a NoSQL database. You could have a high-speed transactional database like Aerospike. And you could have all these connected together, including streaming data. But from the data scientist's point of view, they can do a SQL extraction and then take that into a data frame or whatever they need to for further work. Or it could go directly into a model for inference. Now, so this isn't just conceptual. There's the OSC, which is open source climate, has actually demonstrated a system which uses a data mesh at the COP27 recently in Egypt with climate data. So this stuff is real. And this is from one of their presentation slides. So as you can see from the flow, we don't have time to go through all the steps, but the key is it's open source. Different people can use it for research. They have positioned the climate data in terms of a product, and then you can fit different models and do different types of analysis with it. And we feel this is very important because we feel that climate data is going to have a major impact on the financial systems, and we want to get our hands around this. Now, as you all know, AI works best with lots and lots of data. In fact, you may have heard the opposite end of it. We've had some economists come to us and say, well, we've taken your, we tested out TensorFlow and we didn't like it because we compared it to something we were doing with a logistic regression and it didn't do any better. And we said, well, yeah, of course it didn't do any better because you still have 3 variables. And we're talking about, thousands of variables, and then the logistic regression doesn't work so well, right? So we're looking at creating models which can combine very wide data, data from both climate and finance and geospatial data, so you can actually see what the impacts are. So you can do a forecast of how are the banks in Florida or insurance companies affected by a flood. How does it affect housing afterwards, refinancing, and so on, by having all that data available as input to a deep learning model. This is an example of something they're doing in France, where they can go from a satellite image to identifying where the houses are to actually building a graph network, which can then be put into a graph database automatically. And they're doing this throughout France now in one of their AI projects. We could be doing the same thing. So being able to turn images into data is another way you can get another source of very important things, because ultimately we believe that network data, although we're not exploiting it at this moment, but wish to, is the key to understanding a lot of the complex relationships, and also is extremely valuable in financial crime analysis, money laundering, or how things are going down the blockchain in terms of cyber terrorism and other ransomware incidents, which we have to worry about as well. In fact, there are all these people made movies about cyber attacks on the financial system, and it's something that could happen, so we have to be prepared. So I'd like to talk a little bit about geospatial AI and geospatial data in particular. One of the things that's interesting about geospatial data is if you know the location of something that happens and the time at which it happens, even if you have completely different data sets which have no key to join the data together, and you actually can join the data with that information. So now you could take data sets which were made by different organizations for different purposes and model the impact. So you could say, okay, there was a disaster at this location at this time, and you could check to see what the financials were and what the economy's reaction is, which is a very powerful way of combining information. So it's more, not that the environment isn't important, it's very important, but it's more than that. It's a way of containing data through different lenses and building models on it simultaneously. So I'm going to go through these because I don't want to run out of time, but I think you get the idea from my description. And another area is hazard data, which is a little bit different, but it's related. So you have FEMA collects sets, and they're publicly available, of all kinds of disasters that they've had to deal with. Other companies, insurance companies, have these data sets as well, and a lot of them are widely available in open source. Wouldn't it be nice to be able to combine that data with financial data and with the assets of the company? So you could say, and look at correlations and effects and try to model what actually happens to banks, what actually happens to other financial organizations and systems in disasters. And this is something that would be very useful in mitigating disasters and preparing for future problems. So, bad actors are a problem. It shocked me when I found out. I actually went to a tech sprint, which is like a hackathon, over in London a few years ago. It was right before the COVID. And did you know that, this was what they told us, and they backed it up, that only 1% of financial crimes are detected. So that means 99% of all the money laundering, all the money that's being made and hidden, the human trafficking, illegal drug dealing, and all other things, which we can imagine, aren't caught. So if we could catch these criminals and stop it, it would be very valuable. And things like cyber currencies have made it even more difficult to trace. But these things can be solved. There are companies which are now developing software which can track things through the blockchain, and they were effectively used to catch the cyber terrorists who shut down the oil transport in the South recently, and they were paid a ransom in Bitcoin, and they were caught. So it can be done, and it's something that I believe Federal Reserve should be actively monitoring the blockchains as well as the banking transactions so they can be correlated together. And this can be done with a graph network and the appropriate algorithms. The company in New York, which is doing this already, which we're taking a look at. And this is an example of one of their outputs, and you can find this company on the internet. They're called Chain, and it's ALYSIS. It's not quite chain analysis, but you can find it. And the lighter the color, the more money that's routed through the node. and they were involved in catching the cyber criminals. And there's no reason why, with a large enough graph network, all the banking transactions and blockchain transactions could not be correlated and traced and protect the financial system. And again, I know people talk about it a lot, but I do want to mention it one more time, that financial risk prediction is deeply tied and will be tied more with climate. And we have to start all the, we're worried about all these financial risk models and bank stresses, but climate is not one of the stresses that we currently require. We have to build a case for it, that people in the Federal Reserve think it should. It's not official policy, but we're looking at it, and there are techniques that can be used, I've talked about, to tie these things together, and there's another great application of AI and machine learning. And in summary, because I threw a lot at you in 30 minutes, I just want to go over the key points again. The data mesh is an important concept. I mean, it sounds, some of it's hype, I admit, from different companies trying to sell their product. But it's a good idea to have a data catalog in any company so people can search and find out what's available. Because right now it's pretty much word of mouth if you want to get something. Or you call the department and see what you can get. And they point you to a directory and there's a bunch of files there with strange like codes and you have to open it up and see what the schemas are. It would be much nicer if it was all handed to you in a catalog. And it's, it's many vendors which are selling this capability right now, so you don't even have to develop it. You just have to bring it in-house and turn it on and have it start searching your databases. And this can be connected to governance systems, which are also available, which can have policies, so the security people can be assured that personal information won't be revealed. They have algorithms which can detect personal information, and there are other ways of anonymizing it. So all this can be worked out through policy. So there's no reason why data scientists and companies shouldn't be able to find the data they want and build the models in a very frictionless way. And I think that's the future, and I'd like to encourage you all to ask for this kind of thing wherever you are. And I think that going into a real-time streaming data event processing architecture is the way to go in the future, because we've gotten too used to having someone extract data from databases, mailing it to us as a CSV file, reading it in, running the model, and then you've done all this work cleaning it up, and then it's dead because next month there's new data and it has to be done all over again. And there's no reason why this can't be made systematic, and that your work can continue through a streaming system to go through the same types of transformations it needs automatically without you doing it again and again and again, and be available. If you build a dashboard, someone else should be able to find it in the catalog and use it to feed some other system and connect the things together. Before you know it, things are happening much, much faster than they ever did before. And the other thing is that when building these systems, a lot of times people will either go towards a very fast transaction distributed database system like you would use in a payment system, or they look at something which is an analytical database which can connect to a lot of things and is very good if you're doing a big batch of queries, but has very bad latency properties. They're both valuable, they're both needed. But you should have a choice, and they both should be part of the data mesh that you assemble, and they both should work through the same systems, again, separating compute from data, so you're not limited to which type of database technology you use. And again, just to point to using very wide data and combining things from different sources rather than just sticking with financial information if you're a financial regulator. I'm sure these things translate in other areas, but I'm just speaking from the perspective as a data scientist at the Federal Reserve. That's it. Any questions? Yes?
What is your end user like interacting with the data that you are aggregating and like doing modeling on, whether it be like you're seeing a trend in how past financial markets were or past like volatility was affected by the weather? Are people seeing like kind of charts, or are you scoring like risk, or is it trend analysis? What's kind of like the end user?
Right now, it's in its beginning stages. In fact, we just ran something we call Crunchathon because one of the executives doesn't like the sound of hackathon, which is the shirt from that, which we just did last week. And a lot of people were introduced to this for the first time. So there's a lot of visualization, a lot of, very nice geospatial maps and bubbles of different size, but we hope that this is going to go much further than that and that we'll be able to make some real impact. But that's all down the road. Yes?
Maybe almost building off of that, in particular, I'm curious if some of the geospatial examples are things that are being done currently. If so, are you using GIS and other things, or just more generally, since you're at the beginning stage,
No,
what's your data?
we're using GIS.
Oh.
Yeah.
And maybe the proportion cloud versus on-prem?
Well, the public data that we're using, we use in the cloud. The proprietary data is still on-prem because our security people haven't given us the okay, move it into the cloud. But we hope to be there by 6 months from now, say. But, there are certain roadblocks. Knock on wood, but the Fed has never been hacked. So they say to us, sorry, but look at all the other government agencies that were affected by solar winds and things like that. So they really are very difficult security people that we're getting there.
Split at this point, or majority on-prem?
I think we're doing a lot of interesting work in the cloud, so the more sophisticated analyses require that. Especially we found with the GIS data, it takes a lot of compute. That's almost all in the cloud. But the things like the example of the NLP work that I described is on-prem. Yeah.
Vendor analytics platforms, or do you write your own internally? Is it all proprietary?
No. We use vendors. Our data science group reviewed a lot of them, and there were a lot of good choices. They ended up with Domino Labs. They like that as a platform, particularly because they didn't want to be, some of the other systems, Databricks looked very interesting as well, but it was just more or less a Spark environment where Domino allowed a choice of distributed compute, which they preferred. Any other questions? Yes?
Yes, hi. My question is not directly pertaining to the topics we just covered, but it's also an area where I think AI/ML could be very much helpful. I'm with OSFI, the Canadian financial regulator. At OSFI, we have a team dedicating to do horizon risk scanning, detecting emergent risk. So I'm just curious to know, at Federal Reserve Bank, have you done any project in relation to horizon risk scanning? And if so, what type of tool that you have developed or acquired, like a third-party tool? Thank you.
I'd like to hear what you're doing. The only thing that I know that we've done, there are many groups, so I can't speak for the Fed, but we've been interested in looking at the new topics that come up in all the bank documents that we see. So we, train the model constantly, and if we see that there's new phrases and new vocabulary coming up, a lot of the things people know about as it gets detected, but you do see a big correlation. Certainly, when the pandemic was coming up, we saw a lot of things about COVID and things. But I wouldn't say it gave us a warning because we knew about it. We see a lot of climate things, but we know about that. We're hoping to come up with some of the results that you're talking about by looking at the geospatial data and the hazard data, but it hasn't materialized yet. I'm just curious, could you, in a few words, say what you guys are doing?
Office of the Superintendent of Financial Institutions Canada.
Yeah.
So we are like Federal
I
Reserve
can
Bank.
use the mic so everybody can
I'd like to hear what you're doing.
Yeah. I think everybody should see it. Sorry, no, I work for OSFI, Office of the Superintendent of Financial Institutions Canada. We have like this long-ass name, so nobody can remember. But the short form is OSFI. So OSFI, O-S-F-I. Yeah, so it's a very Canadian thing. OSFI, I work for a dedicated team where we actually focus on data science and apply actually exactly what it is, applying data science to the regulatory work. So one of the area currently a project we're doing is horizon risk scanning. So that's why it's very much interested, like for me to understand other sister regulator, what they do and how they do the horizon risk scanning. So. Well, it's about the risk that has not identified as a risk. As a regulator, we constantly want to make sure that we can detect and make alert of anything that could potentially become a risk so that we can avoid something like 2008 happen, right? So normally we use some sort of, there's the Meltwater, which is a third-party news intelligence tool that could be something that we use, or another news scanning tool, but they're all not exactly covering the area that we want to detect all the risk that potentially hiding somewhere. We cannot read thousands of millions of articles online, so there must be a way to help the human labor-intensive work to help us to find the signals where we can find those emergent risks.
What you're saying. Can everyone still hear me?
Yeah, you projected.
Okay. So we do have a project that does news scanning. There's actually, I forget the exact algorithm, but I think it's like Delft or something like that. It's Google Cloud has it, so you can look at a big query, and they have it as a data set. It's updated every 15 minutes, and it's a summary of international news from around the globe. They have hundreds of different sources, and it's also processed through an algorithm they have to identify the country and if it's a threat. And we have people who are visualizing and looking at that information. In fact, I saw a demonstration of that actually at the hackathon that we gave. But it's very preliminary work, but I think people are aware of that, and I would be interested if you could get in touch with us and tell us more. We could learn from what you're doing.